Hello everyone, welcome to the third lesson of our GoLang course. In this lesson we are going to learn more about the int or the integer data type that we introduced in the previous lesson. First we are going to discuss the int data type, then we will move on to another integer data type called the unsigned int. In the third section we are going to discuss some other related data types, and in the fourth section we will jump on to the code. The data type int can be used to store positive or negative integer values without fractions. Some examples are 100, minus 2, 3, 4, 500, etc. If you try to store a fraction in an int data type, the fraction part will be dropped. The int data type has different variants like int 8, int 16, int 32, etc. These variants have different sizes in memory and as such have a different range of the integer values that they can store. The first bit in memory for int data type holds the sign of the value. It tells if the value is positive or negative. The rest of bits are used to store the value itself. So let us look at all the integer data types. First we have int 8 integer data type. Int 8 data type uses 1 byte or 8 bits in memory to store integer values. Again, since the first bit is used to store the sign of the value, the available bits to store the actual values are 7. As such, the range of value it can store is between and inclusive is equal to minus 128 to 127 positive, which is approximately equal to 2 raised to power 7. If you consider 0 a positive value, 2 raised to power 7 is 128. There you have it. You can store 128 positive values and 128 negative values. Similar to int 8, there is int 16 which uses 16 bits in memory to store integer values along with their sign. Again, the first bit is used to store the sign of the integer value and the rest of the 15 bits in memory are used to store the value of the integer. The range of value that you can store in an int 16 data type is between minus 32768 to positive 32767. Again, if you see 2 raised to power 15, which is the available bits, we have 15 bits is equal to 32768. So if you consider 0 a positive value, you can see that you can store 32768 positive and 32768 negative values in an int 16 data type. Similar to int 8, int 16, we have int 32 and int 64. By now you probably understand that number in the suffix of the data type tells you how many bits are used in memory to store the numeric value. Int 32 uses 31 bits of memory to store the value and 1 bit of memory to store the sign of the value that it's storing. The range of values that it can store is greater than both int 8 and int 16 since it has more bits to store the value. Similarly, int 64 uses 63 bits to store the value and 1 bit to store the sign of the value stored. The range of values it can store is greatest among the signed integer data types. Next, let us have a look at another integer data type called unsigned int. As the name goes, you can only store positive values in this data type. Since this too is an integer data type, the fraction will be dropped if you try to store a value with fractions. Similar to our int data type, there are different variables of unsigned int data types. For example, unsigned int 8, unsigned int 16, unsigned int 32, etc. Again, similar to the int data type variant, each of these types have different sizes in memory, as such different range of values that they can store. Since the integer value stores are all positive, all bits in the memory are used to store the value. As such, it has a large range and it can store large positive numbers. First up, we have unsigned int 8. The unsigned int 8 data type uses 8 bits to store the values. It can store value from 0 to 255 inclusive, which is equal to 2 raised to power 8. Actually, 2 raised to power 8 is 256, but 0 is considered a positive value, so in total you can store 256 values. Similarly, we have unsigned int 16, unsigned int 32, unsigned int 64, which use 16, 32 and 64 bits of memory to store the values. The range is in the column on the right. By now you should get a hang of telling what an integer data type size is in memory by looking at the name itself. Let us look at some other data types related to int and unsigned int. First up is byte data type. Byte is an alias for unsigned int 8, which makes sense since 8 bits of memory constitute 1 byte. The byte data type is usually used to represent raw data. Next, we have the Rune data type. A Rune is an alias for int32. The Rune data type is related to strings. We will cover that in the future lesson. For now, just remember a Rune is an alias for int32. The last ones are unsigned int and int. So you may ask, what is the size of int and unsigned int, as there is no suffix number attached to the data type name. The size of these two types is actually dependent on the architecture of the machine. For example, if your program is running on a 32-bit computer, the size of unsigned int and int in memory will be 32 bits. On a 64-bit architecture, it will be 64 bits in memory. Usually you would use int and unsigned int whenever required instead of the size specific integer data type, which should fulfill all your programming needs, unless your program is going to run on a varying architecture machine. For example, if you are writing a program that will run on laptops, embedded machine, IoT devices, etc., you should explicitly specify the int and unsigned int value that is enough to accommodate the number you are storing. If the value you are storing in a given data type surpasses the maximum or minimum value it can store, it will lead to an overflow error. Let's practice these data types with code now. As I told you before, we are going to explore the integer data type and all the related data types to it. So let's first create the main.go file. Inside main.go file, we will create package main, and inside package main, we will create func main. First, I'm going to create a variable of type unsigned int. Var small positive value is of type unsigned int 8. So I've declared the variable. Now I can assign a value to it. fmt dot println small positive value. If I run the program now, go run main.go, you will see 10 printed to the console. Now, since small positive value is of type unsigned int 8, it can only store minimum or a limited value between the range of 0 and 255. It cannot save negative integers. So if I try to save a negative value, we will get an error. You see that we have an overflow error. The editor here is smart enough to let us know that this will result in an overflow error. This will also cause an overflow error if I use a value that exceeds the maximum limit. So if I use 260, you will see that there's an error. So next we are going to create a variable of type int 8. Var small positive negative int of type int 8. Small positive negative int can be assigned value -10. It doesn't complain because if you remember from the lecture, it can go up to -128. Alright, but if I try to exceed the value, it will complain again. So let's print out the values. Go run main.go. The other integer types like unsigned int 16, unsigned int 32, unsigned int 64 are very similar to unsigned int 8. Only difference is the range of values that they can store. Similarly, int 16, int 32, int 64 are very similar to the int 8 value that we used. The only difference is the range of values that it can store. If I create a variable of type int, as you remember from the lecture, it will be dependent on the architecture. The size of this variable will be dependent on the architecture and the values we can store on it. So I can store a really large value and it should be fine. Now if I want to save the unsigned int value into myInt, which is of type int, myInt is equal to small positive negative integer, you can see it's converting it to int. Even though this is int 8, which is a type of int, it still needs to convert it to int. That's because Go is strongly typed and int 8 are considered different types. I can also do myInt and do small positive value only, which you remember is unsigned int 8. Again, it will be typecasted into int. To typecast a value, you type the type on the left side or the type you are converting into, and then brackets inside the value you are typecasting it, like we did above. That's how we do typecasting. Now, typecasting can only be done for types that can be converted. So I can convert unsigned int into int. But if I try to convert a string value or typecast into typecast a string value into int value, the compiler won't do it. So only like types can be converted into each other. Let's get rid of this line. Next, we will look into the byte and the Rune types. Var my byte is of type byte, and I can assign the value on the same line. fmt println my byte. So here I am assigning it a value of uppercase A, which is in the ASCII range, or it can be stored in a byte. So when I print it, you will see that the integer value for my byte is printed. Go run main.go. You see here 65 is the ASCII code, or the integer value for A, or uppercase A. If I try to assign my byte values that are bigger than a byte can hold, the compiler or the IntelliSense here will start complaining. It again leads to a compilation error. Byte is mainly used to represent raw data and also to distinguish between unsigned int 8 and byte, since byte is an alias for unsigned int 8. Cool. Now let's move on to our Rune. Var my Rune of type Rune is equal to uppercase P. Rune is an alias for int 32. It can be divided into 4 bytes. Rune is closely related to strings because Rune is basically used to represent a Unicode code point. I will talk more about this in the strings lesson, but strings in Go support Unicode, and Go uses UTF-8 to encode that Unicode. And when you encode a Unicode character using UTF-8 encoding, each character can take up to 1 to 4 bytes. So that makes sense why we are using int32, which is total size of 4 bytes. Again, you will see that the integer value will be printed for uppercase P, 66 being printed. So now if I try to assign Rune or my Rune a emoji like this, that should work fine as well. I can do fmt println and that's the integer value for the byte data stored in my Rune. If I add a space in front of the emoji, you will see that the IntelliSense is complaining about it. That's because it's overflowing the value that can be stored in my Rune, because there are 2 characters, and if you remember correctly, one Unicode character can take up to 1 to 4 bytes. So we cannot store 2 Unicode characters that can take up to 1 to 8 bytes in one Rune. That's it for our coding session in our int data types. I hope you enjoyed it. I haven't gone over all the int types, but that's because I want you to practice it. Try playing around, try typecasting, try converting, and try printing the values. Try to see what you see, and try overflowing and see how much values you can store, and try playing with it. Thanks for watching this video. If you have any questions, please reach out to my Discord server. I will post a link in the video description. You can also leave your comments and I will try to respond as soon as possible. Thanks again for watching. Happy coding.